everyone, I'm Eddie. Welcome to my channel. I put together an SAT math module of 22 difficult problems that you can grab right now using the link in the description. The fastest path to an 800 is repetition on the right problems. Now, let's get into a speed run of the 22 problems that decide your SAT math score. It's time to lock in. Number one, if f of x is equal to this function, what is the inverse of f of x? A little trick here we can use is change f of x to x and swap these x's for a y. So we have 2y plus 3 all over y minus 1. Now we want to isolate the y variable. We're going to multiply both sides by y minus 1 in order to do so. We'll have x times y minus 1 is equal to 2y plus 3. Now let's distribute this x to both of these terms. xy minus x will be equal to 2y plus 3. And since we want just one y by itself, we're going to move all the y's we have to one side of the equation. So you have xy minus 2y is equal to x plus 3. Factor out the y, and we'll have x minus 2 here, and you can kind of see where this is going. After we divide both sides by x minus 2, we will have the inverse of f of x will be x plus 3 over x minus 2. Answer choice A. A quadratic has roots 2 plus radical 3 and 2 minus radical 3. What is the equation? Don't think too much about this. If we build a binomial times another binomial off of these roots, we will have x minus 2 plus radical 3 times x minus 2 minus radical 3. Now, notice how negative times a negative will be positive. So far, we are looking at answer choices A and B. Now, let's go ahead and multiply 2 plus radical 3 times 2 minus radical 3. Well, this is a binomial times its conjugate. This is a difference of 2 squares as our result. So 2 squared minus radical 3 squared is what we'll get. 4 minus 3 is simply a 1. That's why A will be our answer here. Solve for x. The SAT loves these types of problems. It's just finding the same base. This is 3 to the x plus 1. 81 can be rewritten as 3 to the 4th power, and that's going to be multiplied by 2x minus 1. So x plus 1 will equal 8x minus 4. Solve for x. 7x will equal 5, and x will be 5 over 7. Easy peasy squeeze the lemon. If x plus 1 over x is equal to 5, find x squared plus 1 over x squared. Our intuition tells us to square both sides of that initial equation that we have. So we'll have x plus 1 over x squared, and that will equal 5 squared. We squared both sides. Now on the left, it's easy to think that this will just equal x squared plus 1 over x squared, which is what we want. However, we must remember when we square two terms, it'll become x squared plus 2ab. So 2 times x times the 1 over x plus the 1 over x squared will equal 25. Now this is what we want right here. But 2x times 1 over x, the x is canceled. So if we subtract 2 from both sides, we're left with 23, and that will be our answer. Number 5, a function satisfies f of x plus 2 is equal to f of x plus 6. If f of 0 is equal to 1, what is f of 6? You know what? Let's just plug right in. If x is equal to 0, then we have 0 plus 2, which is f of 2, will equal f of 0 plus 6. That's 1 plus 6, which is 7. Now, we know what f of 2 is. We can plug in f of 2. So f of 2 plus 2 will equal f of 2 plus 6. Well, f of 2 we found is 7. So now we have 7 plus 6 is equal to 13. And in order to find f of 6, we can find now f of 4, which is equal to 13. But here I'm going to add a 2 to the 4 in order to plug into my f of x plus 2. Will equal f of 4 plus 6. That'll be 13 plus 6, which is equal to 19. How neat. Number 6, solve this problem. Now, I want to multiply both sides by x minus 3. If I multiply both sides by an x minus 3, I will get x squared minus 9 on either side. So all real x is tempting. However, x cannot be 3 because if we plug in 3 into our original equation, we get a 0 in the denominator on the left here. So A will be correct here. 10-second question right there. Number 7, find the sum of solutions. Ooh, love these types of problems. Quadratic equations that equal 0. In order to find the sum of solutions, all we need to find is negative b over a. So now b is negative 7, so we have negative 7 all over a, which is 1. That gives us a simple 7. Don't waste your time with the quadratic formula or anything like that, or graphing on the calculator or anything like that. Just plug it in. This is called Vieta's formula. One of Vieta's formulas. Given 2 to the x plus 2 to the negative x is equal to 5, find the value of 2 to the 2x plus 2 to the negative 2x. So it looks like we're going to be multiplying these x's in the powers by a 2. In other words, we are squaring both sides of this equation once more. So we'll have 2 to the x plus 2 to the negative x squared is equal to 5 squared. Now, don't forget again, when we square things, we will have something like this. But in the middle, we'll have 2 times AB. So 2 times both of these will equal 25. Here is what we want on the left. So as long as we subtract whatever this is from both sides, we will get the answer that we want. Now 2 to the x times 2 to the negative x, this is the same as 2 to the x minus x, which is 2 to the 0, which is just 1. So again, it looks like we're subtracting 2 from both sides. 23 will be our grid-in answer here. Number 9. X minus 1 over x plus 1 is equal to 1. Now, let's think about this for a second. If you have a number and you subtract 1 from it, and if you have a number, you add 1 to it, will those two things ever be the same? Because in order for a fraction to equal 1, the numerator and denominator must be equal. But in this case, x minus 1 and x plus 1 will never be equal, so there is no solution. The parabola y equals ax squared plus bx plus c has a vertex at 2, negative 3 and passes through 0, 5. What is a? This is not that challenging of a problem if you think of vertex form right away after seeing vertex. However, if you don't think about vertex form here, this question is nearly impossible because you will get an equation with 2 variables which you cannot solve. So what we do here instead is we set up a times x minus h squared plus k. Our vertex is 2, negative 3. So that gives us y is equal to a times x minus 2 squared minus 3. We know that 0, 5 is a point that this parabola passes through. So we'll plug in 0, 5. 5 goes for y, 0 goes for the x, and from here, it's just simple arithmetic. Negative 2 squared is positive 4. So a 4a minus 3 is equal to 5, 4a is equal to 8, and therefore a is equal to 2. Number 11, absolute values. SAT loves them. Now, x plus 2 plus x minus 2, both within absolute value symbols, equals 10. The easiest algebraic way to do this is to consider both the positive versions of what's in the absolute value and the negative versions of what's in the absolute value, as we've done. So 2x is equal to 10, therefore x is equal to 5. Here we have negative x minus 2 minus x plus 2. We get negative 2x is equal to 10, x is equal to negative 5. We could have answered B right after we found x equals 5, but again, we just want to make sure that we're doing this correctly. And guess what? We're already halfway through the module, 11 out of 22 problems. We can take a breath. Reminder not to rush, and this is where we start to lose a little bit of focus because this is the second module. You saw 33 math problems so far out of the 44 total. Take a deep breath, have some water, and let's keep going. Number 12, 2 machines working together complete a job in 6 hours. So these 2 machines working together finish one job in 6 hours. One machine alone takes 10 hours. So one machine alone for the entire job takes 10 hours. How long does the other machine take alone? So one job, the same job, how long does the other machine take? But together, they take 6 hours for the job. This is how we want to think about it, as ratios. Now, this is a simple fraction equation. 1/10 plus 1 over x is equal to 1/6. So 1 over 6 will equal, 1 over x will equal 1 over 6 minus 1/10. We can look for a common denominator. In this case, that common denominator will be 30. So we have 5 minus 3, which is 2 over 30, which is 1 over 15. Our final answer will be 15 hours. 15 would be your grid-in answer here. Number 13, the price of an item, let's say it is x, increases by 20%. So x times 1.20, since it's increased by 20%, then decreases by 20%. So decrease by 20% means we take 80% of it. What is the overall percentage change? If we multiply 12 times 8, that gives us 96, and this will become 0.96 of x. You can plug it into a calculator as well to check. That shows that the overall percentage change is just minus 4%. A town's population decreases by 12%. Wait, let me just make sure I did this one correctly. 8 times 8 times 1, 8 times... Okay, great. Yeah, we did it correctly. A town's population decreases by 12%. So if it decreases by 12%, that means we now have 88% of the population left. If the population is 25,000 now, which is the initial value that all of these have, which expression gives the population n years from now? Since we're decreasing 12% each year, we're left with 88% after each year. 15. A tank contains 30 liters of solution that is 40% acid. The first thing you should do here, don't read the whole question ever, just go step by step. We have 40% of a 30-liter solution is acid. What is that? That's 12. 12 liters of acid is how much we have. How many liters of pure water must be added so that the resulting solution is 25% acid? So no more acid is being added. So our final liter amount of acid is still 12, but now only 25% of our entire solution will be acid. We're adding a certain amount of water. So to this 30, our initial tank that contains 30 liters of solution, I will be adding some liters of water. That's x. Now 0.25, divide both sides by 0.25, or since we know 0.25 is 1/4, we can multiply both sides by a 4. And that gives us 30 plus x. So we are adding 18 liters of pure water. And that resulting solution will be only 25% acid. 18 would be your grid-in answer here. Number 16, a car travels 45 miles at 30 miles an hour, and then another 60 miles at 60 miles an hour. What is the car's average speed for the entire trip? Average speed will be total distance over time, the total time traveled. The total time traveled, we're not sure yet. We can figure it out. We do know the total distance, though. That's 60 plus 45. Now, how do we find the time? Well, let's split these up. 45 miles divided by 30 miles per hour will cancel out the miles and bring the hours to the top. This gives us 1.5 hours. Next, we have 60 miles. This one's even easier. In 60 miles per hour, that's 1 hour. So total, we have 2.5 hours. And if we do 105 divided by 2.5, I believe that will be 42. 42 miles per hour will be our average speed for the entire trip. Don't ask me how I did that in my head. I know that, or actually, let me show you. 2.5 times 2 is 5. And so I did 105 divided by 5, which is 21, and multiplied by that 2 that I multiplied the 2.5 from before. Number 17. In a class, the ratio of boys to girls is 3 to 5. If 8 more boys join, the ratio becomes 11 to 15. How many girls are in the class originally? All right. This is a proportion. A proportion means we could have 30 boys and 50 girls. We could have 300 boys and 500 girls. We don't know. So essentially, we have 3x over 5x. Excuse me. Now, if 8 more boys join, I'm adding an 8 to the total number of boys. Now my ratio becomes 11 to 15. How many girls are in the class? We are looking for 5x. And I'm going to put a star here because oftentimes, because this is a graded question and we do not have answer choices, once we solve for x, we might be inclined to just put whatever x is equal to into our graded answer. But we need to not do that. And a way to avoid that is to write 5x is equal to what? That's what we're looking for. It serves as a reminder, even when we come back to check our work, that that's what we're really solving for. Let's cross multiply or use the butterfly method, whichever works for you. 3x times 15 is actually the same thing. Plus 8 times 15 is 120. We have 55x. We're going to solve for x here. Subtract 45x on both sides. X is equal to 12, and that's our answer. Nope. We got to plug this back in into x. 5 times 12 will give us 60 girls are in the class originally. That will be our graded answer, 60. Number 18, 2 bacteria cultures start growing at the same time. Culture A starts with 200 bacteria and doubles every 3 hours, okay? And since we're talking about 15 hours, it'll be 2 to the 5th. Culture B, this is A. Culture B starts with 400 bacteria and doubles every 5 hours. So we're doubling still, but every 5 hours will be 3 times within the 15 hours. How many more bacteria does culture A have than culture B? Well, 2 to the 5th is pretty simple. That'll be 4 times 4 times 2, which is 32. Times that 200 gives us 6,400. We have 2 cubed, that's 8 times 400 is 3,200. Subtract these, and you get 3,200. Number 19. This is probably one of the most difficult ones, and usually the last few problems on Module 2 will take you the longest amount of time, or will have a very sneaky trap where you may be making mistakes. This is where you'll be making the mistakes right here. Given that x plus 1 over x is equal to 4, find the value of x cubed plus 1 over x cubed. You can kind of tell that our most common answer here will be 64 because we'll just cube both sides, but that is incorrect because when we cube x plus 1 over x, watch what happens. If we have x plus 1 over x cubed, this will be, let's write it out right here, a plus b cubed is a cubed plus a squared b, 3a squared b. Let me rewrite that here after I erase this. Plus 3a squared b plus 3ab squared plus b cubed. What does this remind you of? 1331, Pascal's triangle. We love Pascal's triangle. So let's do the same thing. We have x cubed plus 3 times x squared times 1 over x plus 3 times x times 1 over x squared plus 1 over x cubed. Now, if we highlight these, boom, and boom, we got it right here and right here. So we just need to figure out what this middle portion is. Now we know all of this is going to equal 64 because 4 cubed is 64. Let's figure this out in the middle. Let's isolate this and see what we get. X squared divided by x is just x. X and one of these x's cancel out. Guess what? We have a common factor of 3 here. We can factor out of 3. We'll just be left with 1 or x plus 1 over x. And what is that equal to? It's equal to 4. So we have 12. If we subtract 12 from both sides, 64 minus 12 gives us 52. And that would be our grid in answer. A very neat and simple problem if you think about it. But it really goes to show that we need to know our distributive properties here. One quantity doubles every 4 hours. The second quantity triples every 6 hours, which grows faster over 3 days. So if we are doubling every 4 hours, over 3 days, that's 24 hours times 3. That's 72 hours. So if we have 72 divided by 4, that will be 18. The second quantity triples every 6 hours. If we divide 72 by 6, that's just 12. So we're thinking about 2 to the 18th or 3 to the 12th. Let's do that really quickly here. You can use a calculator. You can use the calculator on the screen on the digital SAT. I'm just going to use my phone here. 2 to the 18th is equal to 262,144. And then we have 3 to the power of 12. That's equal to 531,441. So which grows faster over 3 days? Definitely that second quantity. Number 21, for what value of k does the equation given have two equal real solutions? Keyword here, equal solutions. This is assessing if you know how to work with the discriminant. The discriminant of a quadratic equation is b squared minus 4ac. It's whatever's within that square root in our quadratic formula. And if it equals 0, that's when we know we have two equal real solutions. So let's plug in b, which is negative k plus 2. But it won't matter whether it's negative or not because of this squared. So we can just square the k plus 2. Minus 4 times a, which is 1. So we don't have to worry about that. And c is k plus 1. Let's solve. So if k squared plus 4k plus 4 minus 4k minus 4. Watch what happens. Something super neat. These go poof in the night. These go poof in the night. So k squared is equal to 0 and k is simply a 0. I know that might be tough to do on a grid-in, just plugging in 0, but sometimes it'll be the simplest answers that you're gridding into some of the SAT math problems. We are finally at the last one. We are currently at about 21 to 22 minutes. We got a minute per problem, and we will have about 13 minutes in this module left to check our work, which is plenty of time. And we didn't rush on anything. I was explaining every problem as well. I think I could have solved this entire module probably within 15 minutes even if I didn't have to explain everything. Again, every problem on the SAT math section is can be solved within 95 seconds. 95 seconds. Let's take a look at this last one. A parabola passes through these 3 points. What is the coefficient of x squared? Now, this is a very challenging problem. This is probably the problem that will keep a lot of students from hitting that 800. A lot of students will get that 780 or 790 because of this type of problem. So lock in. Let's try this out. We have 1, 3, 2, 9, and 3, 19. Let's look at the differences of the y's. 3 to 9 is 6. 9 to 19 is 10. But we're working with a quadratic here, meaning we're looking at the second difference. The second difference here is plus 4. And for any quadratic equation, if you did not know, or quadratic function, the coefficient of x squared, a, 2 times that will always equal that second difference. So a in this case will equal 2, and 2 will be your grid-in answer. Nice work, everybody.
If this was helpful, hit subscribe. I'm posting a lot more SAT math content breaking down specific topics and exactly how to push for that 800. Drop a like if this earned it. It genuinely makes a difference for the channel. Comment below with the SAT math topics you're struggling with most. I read every single comment, and your comments directly shape the problems I build for future videos. If you're serious about hitting 800, don't stop here. I've already covered a ton of specific question types and common misconceptions in my other videos. Go watch those next. I'll see you there.